All right, moving on and into what is going to be transformations. I think some of you may like this better than the constructions, and some of you are doing well with the constructions. You may still be okay with this, but it is a nice little change up here. What we're going to do today is very, very simple introduction and getting used to the notation for transformations. It's very similar to function notation, and we're going to compare it to function notation. Now, you learned function notation in Algebra 1. So what we're going to do in this video is kind of show you how function notation can be then related to translation notation. All right, so let's do that first. We're going to start with these examples here where we have given a function and we're trying to find the output of the function, so the value of the function. So if we're given the function f of x equals 2x squared plus x, and x is 4, we basically just replace the x. See the x here? We replace that with a 4. And then everywhere you see x, you replace it with a 4. Okay, so all those x's become 4s. So it's going to be f of 4 equals 2 times 4 squared plus 4. Everywhere I saw a 4, everywhere I saw an x, I put in a 4. All right, and then you simply solve that. So that's going to be 4 squared, 16 times 2 is 32, plus 4 is 36. I don't want to skip, you know what? I don't want to skip too many steps. This is 2 times 16 plus 4. 32 plus 4 is going to be 36. So f of 4, just carry that down, f of 4 equals 36. X is 4 and the y value is 36. So that means we're talking about, on a graph, we're talking about the point 4, comma 36. Okay? What is the value of this function at 11? So we're going to do f of 11. And we're going to plug in 11, negative 5 times 11 plus 1. That's going to be negative 55 plus 1. So f of 11 is going to be negative 54. And again, that's the point 11, comma negative 54. And then one more real quick. F of 5 so we're going to do 5 times 2/5. Well, actually it's 5 over 1, so the 5's actually cancel. You could put in your calculator, but this just gives you f of 5 equals negative 2. Negative 2. All right, now these three are kind of backwards. They're giving you f of x. F of x is negative 3. So we're actually taking out the f of x and putting in negative 3 here. So we're going to say negative 3 equals this, negative 4x plus 1. Oh, we know how to solve that, right? It's just an equation. Subtract 1, so you get negative 4 equals negative 4x, and then of course divide by negative 4, and you get x equals 1. Okay, so x equals 1 when f of x is negative 3. This one here, f of x is 4. 4 equals x squared minus 5. Add 5, you get 9 equals x squared. The way to solve an x squared equation with x squared, is to take the square root. Now you may recall from algebra that when you take the square root of a number and it's a positive number, you actually get 2 answers. The square root of 9, you might be thinking it's 3. Well, it is, but what else? It also could be what? It also could be negative 3. So the answer is plus minus 3 is actually x equals plus minus 3. Or you could write it out 3 or negative 3, just like that. Last one, 10 equals 5x over 12. Solve for x. I put the 10 over 1, and then I multiply both sides by 12 to solve this equation. Okay, that's something you should have done last year. 120 equals 5x, and then divide by 5. And that's going to give us 24. So x is going to equal 24 for that one right there. Okay, so now that's the review from function. That's the review of function notation from algebra 1. In geometry, we have similar input-output process as I talked about earlier. But what these rules will do, these different rules we're going to see, kind of written as functions, what they will do is one of these 6 things. Or it could be multiple things. It could translate the object, it could rotate, it could reflect, it could stretch, it could distort, or it could increase, decrease the size. And that's called a dilate. That's called dilate, okay? So those are all the different things that having a function rule, and you do it to like multiple points for a shape, what that will do on a graph. It will do all sorts of things. Flip, rotate, translate, stretch, distort, increase, decrease the size. So here's what it looks like. There's a rule function t. It's a transformation rule. It turns out to be a translation. We didn't learn that yet, but t it just stays transformation right now. So there's a transformation that takes x and y and does this. And here's the rule: x plus 3, y minus 6. So rule t will move or map all points x, y by adding 3 to the x and subtracting 6 from the y. See that? You're going to take the original xy, add 3 to the x, subtract 6 from the y. That's what this means. Okay? And we're going to do that on the next page so you can actually see it better. So now, do you see why it's the connection between the functions and the transformations? Because there's a rule. Whatever the rule is, you do the rule, you get an output. So there's an input, there's an output. Now, with functions, you have input-output, the x and the y. In transformations, we have what's called a preimage and an image. All right, the preimage is what you start with, the image is what you end up with. So the preimage is like the x and the image is like the y, right? The preimage, we have a preimage xy and an image xy, actually. But I'm saying like when you're doing functions, input, output, xy, that's why I said that, but I don't want to confuse you. So for a preimage, we're going to have an x and a y. For an image, we're going to have an x and a y. You'll kind of see it better once we do it. So here's the rule, and here's a few examples here we'll run through. So given this coordinate rule t, x, y, x, the one we were just talking about there, determine the image of A, which starts at -1, 5. So what we're going to do is go t of -1, 5. It's not just x, there's x and a y, right? So that's the point we start with, -1, 5. We're starting with that point. That is the preimage. We want to find the image. So we're going to go to what? X plus 3. Well, x is -1. -1 plus 3. Y minus 6. Well, y is 5. 5 minus 6. See that? So all I did is plug in the x and plug in the y. T, -1, 5 maps to -1 plus 3 is 2. And 5 minus 6 is -1. So what this transformation does, this function takes the point -1, 5 and it moves it to 2, -1. It transforms it to 2, -1. Start with -1, 5, ending with 2, -1. So the preimage was -1, 5, and the image was 2, -1. I hope we understand that. Here's another one. Here's a different rule now, okay? And here's a different point we're going to start with. So with the rule, just change colors. With the rule M, it'll take the point 3, 2. And we'll plug in the 3 here, so it's going to be 3 times 3 minus 1, comma, 5y. 5 times y. Y is 2, they're giving us. So the point 3, 2 as the preimage will give us an image of whatever this comes out to be. 3 times 3 is 9 minus 1 is 8. And then 5 times 2 is 10. So the preimage of 3, 2 maps to the image of 8, 10. So its image is 8, 10 under this transformation, under this function. This one is now wanting you to find the preimage. They give us the image, find the preimage. So that's like, remember the first examples we did, the first 6 examples we did? We started off by giving us the x and we found the y. Then they gave us the y and we found the x. That's kind of what we're doing now. We're finding the preimage. We're given the image. So we're given the ending thing. So we know that the x ends at 3 and the y ends up at 2. Got it? The ending result of the x is 3 and the ending result of the y is 2. So what we're going to do is we're going to take what's in our x position, which is right here, and we're going to equal that to 3. X plus 3 equals 3. Then we're going to take what's in our y position, which is the y minus 6, and we're going to equal that to what the y is supposed to come out to be, and that is 2. So we're going to say y minus 6 is 2. Because we know that x plus 3 should come out to 3, and we know that y minus 6 should come out to 2. What did it start with? What did x and y start as? That's what we're trying to figure out here. So this is going to add 6, y equals 8. This one we're going to subtract 3, y equals 0. So that is my pre-image. My pre-image is going to be 0, 8. And my image was given 3, 2. All right, one more here. So now in the x position, the first position is 5x plus 3. That should come out to be negative 4. 5x plus 3 comes out to be negative 4. And then in the y position is 7y. 7y equals, what's in the y position? 11. That is the answer. Actually, on this one, I think, you know what I did? I'm going to back up here real quick, guys. Sorry. You got to erase that or just cross it off. There was a mistake. This wasn't supposed to be negative 411. It was not supposed to be negative 411. It was supposed to be 13, negative 7. There's a typo here. So you got to replace this with 13, negative 7. So determine the preimage of d prime 13, negative 7. That's what I wanted to do. I just remembered it before I was doing that. Okay, so 5x plus 3 then equals 13. And then 7y equals negative 7. All right, that solves a little better. Divide by 7. Y equals negative 1. And then subtract 3, 5x equals 10. X equals 2. Pretty basic, right? So 2, negative 1 is my preimage. And then my image is 13, negative 7. All right, and last one here, last set here, we're going through and we're doing, we want to look at functions as a function machine. You should have learned this in Algebra 1. Functions are a function machine. So the input, there's input and there's output. So you put the number in, the x goes into the machine, right? And then whatever's inside the machine is the rule. And it does whatever it has to do to spit out an answer. So you put in something, it does the work, and then it spits out an answer. So if you input a negative 1 into this machine, it's going to spit out a 4. Why? Because it's going to put in a negative 1. It's going to go where all the x's are, and then it's going to do the work. Negative 1 plus 5. Negative 1 plus 5 is 4. Spit out 4. Okay, so feed me negative 1, spit out 4. That's what the machine does. Input, output, input, output, input, output. Got it? So plug in, plug out. So, or plug in, take out. So we plug in 3. F of 3 equals 3 plus 5, and that's going to spit out an 8. So the output would be 8. Over here, input 0, 0 plus 5, output 5. So if you have an x plus 5 and you're inputting a 0, you're going to get an output of 5. Here, I'm given the output. The output is like the y. It's like the f of x. So we're going to say x plus 5 needs to spit out equals 11. That needs to spit out an 11. Well, what do I need to do to spit out an 11? What do I got to put in? What plus 5 equals 11? I have to put in a 6. If I put in a 6, 6 plus 5 equals 11, my input should be 6. And if you want to solve that out, you would just subtract 5 from both sides, and then you would get x equals 6. And you could do that in your head, but if it's more complicated, you would just solve the equation out. See you tomorrow for practice on this notation and review of functions. See you then.